All right, as we start statistical analysis, again, we're going to start back with stuff that hopefully you know about already. Long pause. So, mean, median, and mode, again, mean's just a fancy way of saying average. I guess they just wanted another M word to blend in with all the other M words here. But again, that's just the add up all the numbers of the data that you're working with and divide by the number of items that you're working with. But we're going to start figuring out which type of data is best to use. Because again, you can mess with statistics to basically make it say anything you want. So, if your data set has no outliers, what's an outlier? No, it's not when somebody says a fib to you and you scream, "Get outlier." That's not what we're up to here. What's an outlier, mathematically speaking?
When, like, a number is like way off from the rest.
Yeah. If we've got a way off number, like if you have a bunch of quiz scores and it's like 80, 70, 75, 80, and then you get a 0 in there, that would be an outlier. So that can kind of screw some things up.
Or like when they would say like a lab, like that, is that when most of the instead of like test scores?
And I would hope so. Yeah, with test scores, you would hope that that doesn't happen real often. But yeah, if you get lab results back possibly that are way off compared to some other things, and we'll see some down here a little bit further with the apps too, but absolutely it happens a lot in science. So if you have a bunch of numbers that are pretty close together, using their mean or their average would be the best route. Median is the middle number or mean of two middle numbers. We'll talk about that discussion when it comes up here, of the ordered data. Ordered again means least to greatest. So if you get a list of numbers and they're not in numerical order, if you're trying to find the mean, that's your first job. You have to get them in order, otherwise you won't end up with the median. Now with a median, you can have outliers, but no big gaps in the middle. Okay? Because again, when you're looking at the median, you're just looking at the number in the middle of your list. So if you have monstrous gaps, that would kind of mess that up a little bit. But again, we're going to get to play with those here in a little bit down below. But again, ordered is the big deal here. Mode, what occurs most often. So if you have data where the same number keeps showing up over and over and over and over again, that would be a good measure of your data. So we do have to be able to figure out which one of these types we want to be able to use when it comes to analyzing whatever information we're trying to get set. And then this is probably a new one for all of you down here on the bottom. It's called the margin of sampling error. And what we do is we do plus or minus 1 over the square root of n, with n being the number of items that we're working with. So if I survey 100 people, I'd use n equals 100. Or if I'm, experimenting with 5 different animals, I'd use 5 as that. And it helps me to see how much of a range there is where that possibility could actually become true. So for instance, example 1, which measure of central tendency best represents the data? And when we're talking about these, we're only talking about the 3 M's here. Okay, not the 4th M with our margin. So, which measure of central tendency best represents the data? So I start to look at those numbers and try to not cheat with the line right underneath it. Do I have any outliers?
Yes.
Okay, I have an outlier. That 159.4 is kind of way out there. So that would whack mean is a good idea. When you have outliers, they'll throw things off. So then, do I have a number that repeats a lot? No, I don't have any numbers that repeat. So mode's not going to be a good idea. So in this case, taking my median would be the best idea. And since the numbers are in order, I could... Okay, if I actually wanted to find the median here, here's what we'd do. We'd start from the edges, and we'd start working our way in. But I notice there's 2 numbers in the middle. So that's when we were talking about here, the mean of 2 middle numbers. This time, since I have 2, I would take those, I would add them up, and divide by 2. And if you're going to the calculator, make sure you either do this part and then hit enter, or use the parentheses, because otherwise you won't get the correct value. So if I really wanted to do that, that would be my median. But y, well, we have an outlier and what's called no modal values, which means I don't have any numbers that repeat. So when you're being asked for y, understanding why you're saying something is important. So don't skip the y's on these. So we're going to do some more of those here in a little bit too. So I kind of start to work my way down a little. And I go, all right, second example. What's the margin of sampling error? We're going to use our formula. And the likely interval that contains the percentage of the population. Of 400 people surveyed in a national poll, 51% say they will vote for candidate Gonzalez. Okay, couple of things. My n value here would be the number of people I surveyed. So it'd be 400. So the margin of sampling error would be 1 divided by the square root of 400. So most of us don't know that off the top of our head. So 1 divided by the square root of 400. Okay, would be 0.05, otherwise known as 5%. So when I'm doing that here, and I'll just put that here to remind me, what it basically means is whatever percentage they're claiming are going to vote for this candidate, there's a 5% rounding error, which means I need to take the 51%, and to figure out on the low side, I would subtract 5% from it. So it could be as low as 46% of the people really are going to vote for him, but it also could go the other way, 5%. So my likely interval would be somewhere between 46 and 56%. Now, the larger survey you do, the more people you survey, the more tests you run, the more accurate you're going to be. Because again, think about it when we've talked about the mathematical way of doing it, the more you do it, the more likely it comes back to what it should be. Okay? So, move this up just a little bit. So which measure of central tendency best represents the data and why for these? Well, let's see here. Number 1, I'm being told mode. Why mode? Yeah, here, out of the 6 numbers, 3 of them are 45s. So in this case, mode is the best option. And again, why? Well, half my data is 45s. So that's going to more accurately depict the data in this case than just finding the average or finding the number that's in the middle. But again, that could be used as my reason. What about the second one? Okay, first question I'd always ask myself on these. Do you have any outliers? Okay, we do. 496 is kind of out there, so that's going to eliminate mean. Do I have numbers that repeat? No, that eliminates mode. And basically, like we'd said before, I have an outlier and I have no modal numbers. I don't have any numbers that repeat. If those 2 tests fail, you're heading to median every time. So it's kind of an easy way to check every time and not sit there trying to kind of beat yourself up figuring it out. What about 3?
Would you put 5 in outlier?
Definitely. So what about for 3? Median again, because again, we have ourselves an outlier. Now, here's the one that gets a little bit tricky. Because some of you may be able to argue, but that's kind of a big gap there towards the middle, which I get, but again, I don't have any modal numbers. I've got myself a definitive outlier here. So for those 2 reasons, Again, we're going to stay with median. And what about our last set of data? Mean. Because here, I see no outliers. And again, this is probably my main reason. But again, those numbers are all somewhat close in value. So somebody may say, well, 44 is kind of up, but it's not way out there. When we're talking about outliers, we're talking about way out. So that's basically all we'd be looking at, you know, which way is going to give us the most accurate depiction of the data that we're working with. And then one more here with margin of sampling error, and then we can get a little deeper. Survey of 28 random people found that 40% read at least 3 books each month. What's the margin of sampling error? Okay, so let's see, how am I going to figure this out? What's my n value this time? 28. So, my sampling error, let's see here. 1 divided by the square root of 28. If we went to the nearest whole percentage, what percent would that be? 19%. So, I'm like, okay, it's 19% if 40% is what the survey said. What's going to be my low and high values? Okay. If I subtract the 21, the 19, I'd be as low as 21%. If I added it, I'd be high. And what basically this is telling me is this person, if they're doing a survey, probably needs to survey more people because that's a pretty big gap. It's almost as big of a gap as the weather people getting the weather accurate. So, just something to kind of keep in mind. So as we flip, and that statistical analysis will come in a little more handy here as we go. Now we get into the fun stuff. All right, new stuff. Measures of variation. So for the following data, determine whether it's a sample or a population. Like, wait a minute, Hardy. Sample or population, what's up with this? Okay, now a sample, let me kind of make a little note up here at the top. A sample is a part of a group. So if I came through and I asked 5 of you your opinion on the fairness of a test, that'd be a sampling. However, if I came through and asked every single one of you what your opinion was on the fairness of the last test, now I'm asking the population what I think. So it's a part versus the whole. And then find the standard deviation of the data. Now I'll show you how to do that in a minute, because there's 2 different ways you can do it, and I'm sure all of you are going to like one way over the other. So round to the nearest hundredth. Now the first one up here is done for you, so I'm going to use the fact that it's done already to explain how you could do it if you didn't have a fancy schmancy calculator to work with. Normally, if we're looking for standard deviation, I'm going to call this manual standard deviation. I'm just going to call it SD. There's 4 steps to this if you're doing it, if you're cranking it out on your own with a calculator. My first job always would be to find the mean. So I'd take my data, I'd add them all up, divide by the number, get my mean. Okay? That's already been done for you here. They added up all the scores, they divided by 12 because there were 12 scores taken and got the mean. Okay, that'd be my first job. My second job is to calculate the difference of the score and mean for each value and square it. And then I'll have a picture for this for you here in a minute too. And then we're going to add those together. And actually that was done on this example in letter B. So you'll notice they did like 61 minus 81.42 squared. 99 minus 81.42 squared. 75 minus 81.42 squared. And they didn't even write all of them. They ran out of room, so they used the dot, dot, dot. I'd have to do that for all 12 of my data sets. And then when I got done with that, I'd add them all up and I'd get an answer. So for instance, here they got 2095.55. You're like, oh my gosh, this is ridiculous. And we're not even done. Again, if I'm cranking by hand, we're almost there. Next, I would have to find the mean of step 2. And this is called the variance. So again, they did that for us here as well in step C. They took the 2095.55 and divided it by 12, because there's 12 scores, and got this thing called the variance. And then finally, if you take the square root of variance, you get standard deviation. Now think about how much of a pain this would be if way back in the day, before all these fancy calculators were around, you had like 300 scores that you were trying to do this for. Spend an hour like on a problem. But luckily for us, we don't have to necessarily deal with this anymore. Instead, what we're going to do, and we're actually going to do it with the problem up above so you can make sure everything's going well. We are going to take that data, move it up a little bit here, and we are going to use the instructions right below on using the graphing calculator to do this. So here's how this is going to work. And if you haven't gotten a hold of one right now, go grab one, because I want to make sure you get all this down. Even though the directions are here for you, so it's not like you're going to have to jot all this down. And you always could use the online one later. Or a lot of you, if you have like apps and things like that, a lot of the graphing calculator apps will have some of this stuff too. It may be named a little bit differently, but it would work the same way. So what we're going to do, okay, now that we got you all situated here, we're going to hit the stat button. It's over here towards the middle up top. If you hit that, the very first thing there is just says edit. Okay? So you can either hit 1 or you can hit enter. Now, if you have numbers in yours, like I do mine, quick way to clear them out. If you up arrow to where it says L1 and hit clear, you're like, yeah, but the numbers are still there, Hardy. Not. Okay. Okay. Hit stat. And then hit enter. And you should get something with like L1 there. Now, if yours is clear, that's awesome. If it's not, arrow up to where it says L1 and hit clear, and then arrow back down and everything will be gone. So this is what everybody's needs to look like right away. Because if it doesn't, oh, we're going to have issues. So once I get here, I do have to take the time, though, to enter in my data. So as I get a number done, just hit enter, and it'll go down to the next line, just like you're using, a keyboard. So as you're typing in your numbers, just type in the number, hit enter. And kind of keep peeking up to make sure we're not messing up any numbers. Just keep hitting enter, 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 enter. One more. Enter. Now some of you may say, now if the list gets longer, how do I even make sure I got all the numbers? They even have a foolproof system for us on this. If I look back, I'm like, okay, there's 12 numbers in the list. The last number that I typed in, notice L1, 12. oh, I've typed in 12 numbers. So I'd feel pretty confident at that point that I've actually got them all. I mean, I could go back up and look at every single one, but especially if the list gets longer, I don't necessarily want to do that. So once I've got those all in, okay, I hit the Stat button again. This time I'm going to right arrow once over to where it says Calc, and number 1 there says number 1, VAR Stats. This is going to do a whole bunch of statistical analysis for us. So once I get to here, Calc and number 1, hit 1 or hit Enter, and this will show up on your screen. You're like, that doesn't look like much, it just says 1 var stats. Okay. It wants to know, though, okay, what do you want me to base these stats on? Well, I want you to base the stats on my list. So to get my list up, I'm going to hit second and the number 1, okay, because I just typed all my statistics into list 1. So by doing that, and now I hit enter, it does a bunch of work for me. You're like, what the heck is all that crap mean? All right, just a second here. We are going to pause while we do some calculating. Now let's talk a little bit about what all these numbers mean. The big number that we want is standard deviation, which is that thing that looks like an S with the X right after it, that 13.21. You'll notice, okay, there's my standard deviation when they did it all the long way. And here's my standard deviation now. Whoa, and there it went, and there it is, okay? So, 13.21. Okay, well, what does the other stuff mean? Is there anything there that could help us? A couple of the things there could help us right now. The X with the line over it, that's your mean. So if you ever had a list of numbers and you were asked to find the mean, you could use the calculator for that. It's kind of cool. The summation notation, that's what that kind of funky looking E is in front. That is the sum, oops, I'm in the way of the calculator. That's the sum of all your data. So if you wanted to be able to add everything up, you also can do that in the list. And there's a bunch of other stuff here, like the sum of the squares of the data and some other stuff. And if you down arrowed, see, it tells me there's 12 terms. And if you are ever doing anything with a box plot, it'll tell you what the minimum value, the maximum value, it tells you the median, it tells you the interquartile range. There's a lot of stuff the calculator can tell you. But for our purposes, standard deviation, mean, and the sum of the data is probably going to be, for the most part, what we're looking for, unless you want the median. So that's going to make this a whole lot easier to work with than what we'd have had to do by hand here before. So let's see if we can make this work here one more time. For these last two, determine whether each is a sample or a population, then find the standard deviation. Okay, so first question on each of these. Is A a sample or a population? Why is it a sample? Because it says sum. Okay, so this is a sample. What about B? Population. Why? All students. Okay, so now let's see if we can put this to work here and make sure this is going well. All right, so we'll get it turned on. We're going to go back and hit Stat. Okay, and we want to edit because we need to change our list 1 from before. So we're going to hit enter. There's my list. I don't want it anymore. So again, I'm going to arrow up to L1 and hit clear, or I could clear each one individually, but that'd take more time. So I have a nice clean list to work with. And now I'm just going to go ahead and type in my data set here. Gotta quit putting my finger over, oops, over data here. What's that? So again, I look, I'm like, I got 12 numbers here. My last number in my calculator says 12, so I'm feeling good. So I'm done with that. I go back to my stat menu, right arrow to calc. I only want to use 1 var stats. 2 is more statistical data that you can come up with, but we don't need all of that right now. Hit enter. Okay, so there's my 1 var stats. I want list 1 now that I've changed it, which is second and 1. And you'll notice right above the 1, there's a little L1 in yellow. In case you forget, you can find it that way, but you'd have to use the second button to get hold of it. And then hit enter.
So like, say if you don't clear out L1, you just put that in L2, and you just put L2, and you just show that.
Good question, and that absolutely would work. Yeah, if for some reason you wanted to keep your data set, your first list from before, you could just move over to L2 and then hit second 2 for L2.
If you're like short on time and you don't want to erase it all.
Yeah, you absolutely could. Yep, as long as you make sure you're getting the right data set, that absolutely would work. So what's my standard deviation for this one? 6.61. And then we always love small data sets. Why am I moving all that over here? I will move the calculator. So one more time here. And let me use Chris's idea so we can actually see that this works. So if I hit stat and I go to hit edit, Chris said, what if I don't feel like getting rid of L1? Okay? That's okay. If I want to, or if you want to keep doing with L1, you can, but just to prove a point, let's say I go over to list 2. So I type in my list here, because maybe I need to go back later and check something, and I don't want to have to take the chance of having to retype the other list in. Okay. And again, I notice my last number says 6. Yep, 6, okay? Now, the only thing that would change for me this time is once I get that in, and I went back to stat, and right arrowed over to calc, so I get my variable statistics, my variance statistics, excuse me, and hit enter. When I go to put in my L, if I typed them into the second list, I'd hit second 2, because I want it to be done with the second list, and I'd hit enter, and it absolutely works. So what's my standard deviation going to be this time? 1.17. And what we'll end up using this for is, there's another portion of this that will come up on percentages of the time that your data is going to be accurate based on the standard deviation. That's what we're going to talk about next. It's called normal distribution, but that'll be early next week that we'll start playing with that. So your job over the weekend is to play with A and B. Monday we will do a practice C and get another piece of final review out to you. And I think we're good for now.